that what they're able to do is they're able to model the development of the universe. You start the universe at time 0, and then you run it forward. You take the current laws of nature and the physical constants that we know from nature at the present moment, and then you apply them to that initial burst of energy. And you say, how would the universe develop if we started the clock at time 0? All right? And you see how it would develop into the universe that we know right now. The universe that has all these stars and galaxies. The universe that presents this spectacle at night of the night sky. And then they say, what if we changed the configuration of the universe just a little bit? We change it in the gravitational constant. We change the weak nuclear force, the strong nuclear force, what have you. And what they find is that if you change any aspect of the physical configuration of the universe in the slightest bit, then the universe would not have developed properly, and you can never get stars and galaxies. You could certainly never ever get a habitable planet such as Earth. And this makes it seem like, wow, the universe is extremely finely tuned by who? So, in other words, the chemical, not the biological, the chemical evolution of the universe had to be very specifically configured. In other words, in my book, I support the idea of a chemical evolution. We can replicate chemicals turning into chemicals. Whereas the idea of biological evolution, life forms coming from non-life, or less complex life forms turning into more complex life forms, that's not replicable, and in fact, it has no empirical evidence behind it. But the Big Bang Theory does have empirical evidence. This is a species of chemical evolution, which is reputable, as opposed to biological evolution, which is not scientifically reputable, as I argue in my book. Part of the book I don't have time to cover today, but you're really going to enjoy it if you read those chapters.